So guys, welcome to the class. What we are going to start today? Today we are going to study about angle of friction. Yes. So till now we have seen that there is a body. There is a body, and body has a mass m lying on a floor. Okay. So obviously there will be a weight acting downwards, that is equal to mg, and there will be upward force. What is this force called? What is this force called? Normal reaction. Yes or no? And when the body is at rest, what kind of friction acts on it? What kind of friction acts on it?
Static.
Yeah. And if the object is moving, what kind of acts on it? Kinetic. Yes. So,
Yes, sir.
and we have also seen that Fs is greater than Fk or Fk greater than Fs. Which one? Which one?
Fs is greater than Fk.
When Fs is greater than Fk. If Fs is greater than Fk, then the body will what? Body will move or does not move?
So it does not move.
No. If F applied is greater than what? Fs or Fk, then only body will move. Your Fs will obviously be greater than Fk. Why? Because if Fs is greater, then only the body will be at rest. Understood? So if the body is at rest, that means the maximum friction is the Fs, and that is equal to F limiting. Remember that. If the applied force is greater than your static friction, or the applied force is greater than your Fk, then only the body will move. If applied force is equal to Fs, the body will not move. If the applied force equal to Fk, then also not move. So only when the applied force is greater, the net force is greater than the friction, whatever friction, it might be Fs or Fk, then only body will move, or else body will not move. Simple. So now, when you're talking about angle of friction, why angle is coming into picture? Now, we have already discussed that there is a concept called normal reaction. There is a force. Yes or no? Force is upward and there is a downward force. Yes. So what? There is another force acting. This is called Fs. What is this force? Static friction. If the body is at rest, then the static friction is always acting this word. Why? Because you are about to pull the body this side. If you are about to pull the body this side, the static friction will act this side. If you are pulling the body this side, the static friction will act this side. Clear till now? Clear?
Yes, sir.
Okay. Now, let's say I am about to pull the body this side. About to pull the body this side. I have not pulled it. I'm about to pull. So static friction is already acting. You have the normal force. Now, remember these two forces. Another force will be given, and this is called resultant force. What is force called? Resultant force. And we also say this as resultant contact force. What is this force called? Both, all of you. What is this force called? Resultant contact force. Understood? Because the body is in contact. During contact between two surfaces, see, this surface, the body surface, and the floor are in contact. Understood? So because of the contact of both the surface, a normal reaction is upward, a frictional force is down, left side. And both the forces, both are vector basically. So there is a resultant force called R. And the angle between the resultant force and the normal is called theta. And that is called what? Angle of friction. Clear? Clear?
Sir, that resultant, it is the uh, vector between the friction and normal, sir.
Yes. Yes.
Okay, sir.
It's basically two vectors. That's it. Nothing else. So you can consider like this. Normal, Fs, Fk. Clear? What is Fs? Fs is mu s into n, and normal friction is how much? Mg. Correct or not? So can I write Fs as mu s mg? Yes or no? Yes or no? And theta is the angle of friction. This is called resultant contact force. Clear? Clear?
Yes, sir.
So I can remember we normally write FL. FL equal to mu L into mu into N. Remember, we always write it. Why? Because limiting friction is the maximum static friction. I told you that static friction extends from F limiting to 0. So it is a variable. It's a variable friction. I told you it's a variable force. It's called self. What kind of force it is? Self-adjusting. What is called self-adjusting? Swaroop, remember what kind of force it is called? Self-adjusting. What? Swaroop. Can you hear me, Swaroop? Laksh, Pritam, can you hear me?
Yes, sir.
Laksh, can you hear me?
Yes, sir.
What happened to Swaroop? Okay. So now, can we reverse this triangle and write like this? This is the theta. This is the n. Okay. And this is the...
Sir, Swarup is texting you.
Sorry?
Swarup is texting you. He is messaging you.
Yeah. So let me revise this triangle. We will reverse this triangle. If I reverse this triangle, this will become n here. This will become r here. And what about this friction? This is the F. This part is this part. So this is the F. Clear? So can I write tan theta as F by n? Can I write tan theta as F by n? Can I write? Yes or no? Yes or no, Pritam?
Yes, sir.
Yes, sir.
So can I write like this as FL as mu L? We'll write as mu L, mu into N divided by N. N will get cancelled. So what we will get? Tan theta is equal to what? Mu S. Tan theta is mu S. If the body is at rest, then tan theta is mu S. If the body is in motion, tan theta equal to mu K. Clear, all of you?
Sir, I have a doubt, sir.
Yeah.
Sir, why are we taking the resultant of only normal and friction, sir?
What we should take then?
Sir, no, sir. I'm asking, sir.
No, because it's a contact force, no? These are the two contact forces, no?
Okay, sir. Like we are not taking the weight and all that, sir.
Why weight will consider? Weight, it is not going inside, no? Is it going inside? Weight is something which is here, no? It is not. Does the body has any motion downwards?
Oh, no, sir. Okay, sir.
The body will only move this side or that side, yes?
Yes, sir.
That's why we are not considering. Clear? All of you clear?
Yes, sir.
Okay. So find out now. There is a mass. All of you try out. Find angle of friction. Put down the formula. Put down the formula. I have everything I have written down. All of you try.
Sir, Swaroop is messaging you.
1/5.
टिकट बुक हो गया, अब चलना है बस। फिर कोई मना नहीं करेगा। ये ऐसे सबसे पूछने जाएंगे ना तो सबके टक्कर निकल जाएंगे।
सबसे अच्छी जगह या तो गुजरात चलो या फिर राजस्थान। गुजरात में द्वारका, सोमनाथ,
राजस्थान कहीं भी चलते हैं कि सब साथ में जाएंगे। शिमला चलो ना।
कितना हुआ?
बहुत जगह बहुत
ये ठंडी जगह में है ना, वहाँ निकल नहीं पाते।
70.
दोनों जाना।
Laksh,
वो ठीक है।
शिमला जाएंगे आप लोग।
शिमला
go to
शिमला
a
नहीं,
room.
इधर मना।
Laksh, go to a room where nobody is there. No, it's disturbing for me. I asked you to find theta. I didn't ask you to find tan theta. Swaroop, you have to find what is theta. Theta will be tan inverse of 1/5. This will be your answer. Don't tell 1/5. 1/5 is tan theta. I told you to find angle of friction. Pritham, have you got it?
One second, sir. Sir, tan theta is equal to 1/2 not sir. Oh, no, sir. Oh, sir. Yes, sir. Yes, sir.
What happened? Sorry.
Sir, no, sir. I made a mistake, sir.
Okay. Clear, all of you? Laksh, किया कि नहीं? What you got answer?
कर रहा हूँ सर.
Laksh, it's very easy, nothing. Tan theta is 0.2. 0.2 is 2/10. 1/5. Theta is tan inverse of 1/5. That's the answer. There's no rocket science. It's very easy. Because I told you starting tan theta is equal to mu s or mu k. Nothing to do. Mu k is always given. You just have to find mu s by mu k.
Clear, sir.
Okay. So now let us go to the next topic. there is a block of mass √3 kg. Okay. Question is, find the maximum value of F. Find the maximum value of F such that the block is unmoved. Means I am applying a force like this. Okay. With an angle 60 degree with respect to ground. Okay. The mu is 1 by 2√3. I have to find 1 by 2√3. I have to find the maximum value of F so that the block does not move. How much I should give F till that it does not move? Means I will start pushing. What is the maximum value of F? Till what time the body does not move? Okay. So now who will tell me that whether this mu is mu L or mu K? Who will tell me? Who will tell me? Mu L or mu K? Pritam.
Sir, mu L means it's actually mu S only, no, sir?
Yeah, mu L is static friction. Limiting friction is basically the maximum value of the static friction. We will always use mu L. We'll never use mu S. Okay, mu L. So
Sir,
this is the
sir,
mu L.
actually, sir, we'll use the same coefficient for static friction also, no, sir. It's actually FL only, sir. It's not mu L, sir. Like for both the things, coefficients are the same, sir.
FL, no beta. Why you are saying like that?
Sir, yes, sir. Like the formula for limiting friction is mu S into N only, no, sir.
F limiting is equal to mu S into N, and FK
Yes,
will
sir.
be mu K into N.
Yes, sir. Like you wrote mu L, no, sir. For that only I'm saying, sir.
Oh,
Like
okay.
the coefficient, there is. Yes, sir.
Oh, it's a error, typo. We will always use FL equal to mu S into N. Remember that. Okay.
Yes, sir.
Okay. Now we want to find out what is the maximum value of F so that a body does not move. Obviously, body does not move means we are talking about a static. That means this is the F mu S. Okay. Remember. So now, whenever tangentially, basically it's an angle. Whenever it is always in an angle, what we should do? You should always split it into its what? Components. Yes or no? Am I correct? So, what we should do? This will be like this. That means there will be a F cos 60 here, and there will be a F sin 60 here. This 60 degree is same as this 60 degree. So how it will be? Basically, you have a n upward. Okay. Yes or no? Downward we have a mg. You have downward mg, upward n. This will be F cos 60, and here again you have F sin 60. Clear? And there is another force this side, FL. The body will not move only when all this force are equal. Means the body only when there is I told you that whenever there is a body and there are 4 forces acting, the body will not move only when all the forces are equal and opposite. Yes or no? Yes or no? When the equal and opposite forces are acting on the body, this force equal to this force equal to this force, the body will not move. Similarly, 2 downward forces, 1 upward force, one this side, one this side. If they're equal, then only the body does not move. Everybody clear till now? Clear or not?
नहीं अब जाएंगे अचार दे दे मेरे को
Hello? Pritam, are you clear?
पागल, 4 बजे से यही
Yes,
हूँ।
sir.
अभी जाएंगे प्रैक्टिस करते रहे तो अभी जाएंगे अभी
Last,
जाएंगे।
I will teach you. Last, please mute.
Yes, sir.
Please try tell your parents I am teaching. It's difficult for me. Other two people are there. Respect them. Okay. So let me redraw the diagram. N upward, weight downward. You have another force F sine 60. This side F cos 60. This side FL. Are we clear till now? Any doubt? Any doubt till now?
No,
Pritam,
sir.
any doubt?
No, sir. No, sir.
Okay. So your N will be equal to F sine 60 plus W, and your FL will be equal to F cos 60. Clear? Yes or no? So can I write this as N equal to F sine 60 plus weight is how much? Root 3 into G. And FL will be, what is cos 60? Cos 60 is how much? 1 by 2? And this will be F root 3 by 2 plus root 3G. Clear or not? Yes? Am I correct? Am I correct? Guys, answer.
Yes,
Is
sir.
it
Yes.
correct or not?
Yes.
Okay. So I am putting F. The value of F is, let's say, 10 Newton. I did not put the F value. F is 10 Newton. So what will be a normal? A normal force become 10 into root 3 by 2 plus root 3G. So this will be how much? 5 root 3 plus root 3G. So if you take root 3 common, it will be 5 plus G. Clear? And your FL will be 10 into 1 by 2. 5 Newton. Clear? Clear? Clear or not?
Yes, sir. Yes, sir.
Okay. But you know FL equal to how much? How much is FL? FL equal to mu S into N. Yes or no? FL equal to mu S into N. Am I correct? Yes or no? But my 5 Newton is equal to FL. Am I correct? 5 Newton is equal to FL. Somewhere did I make mistake? Anywhere I made a mistake? 1 minute. No. 1 minute. Huh? I did a mistake somewhere. Wait. We have to find the maximum force for which the body does not move. Yes or no? So we have to find what is the F. So why did I give F before? I made a mistake. 1 minute. So now your N will be equal to root 3G plus F sine 60. And your F cos 60 will be equal to FL. Yeah? Am I correct? And FL is equal to mu into N. Yes? Now, N value, we will try to put in this formula. So your F cos 60 is equal to mu into N. Instead of N, I will put root 3G plus F sine 60. Clear? Yes or no?
Yes, sir.
Let us take mu as 1 by root 2 3. Mu is equal to 1 by 2 root 3. So I will put 1 by 2 root 3 and this will be root 3 into G. This will be sine 60 equal to root 3 by 2 into F into again 1 by 2 root 3. Clear? So root 3 cancel. Here root 3 cancel. What you are left with? F cos 60 is equal to G by 2 plus F by 4. So what is cos 60? Cos 60 is F by 2. So F by 2 is equal to G by 2 plus F by 4. So can I take this side? F by 2 minus F by 4 equal to G by 2. So let us, G by 2 is nothing but 5. So F is common. So 1 by 2 minus 1 by 4 is equal to 5. So 1 by 2 minus 1 by 4 is how much? 4 minus 1 by 4. Oh, 2 minus 1 by 4. Correct, no? 1 by, from 1 by 2, 1 by 4 is subtract. So 4, 2 minus 1 by 4. F equal to 5. So F by 4 equal to 5. So what is F? How much? 20 Newton. Clear? Clear?
Sir, will you please explain the last part again?
Which part? Tell me. I'll explain again. Which
The
part?
last one.
I will explain again. Don't worry. I'll explain again. Sorup, are you clear? Sorup, please text. No. So what we are trying to equivalent the force. We are trying to equate the force. Okay. So what I did, we have to find the maximum force for which the body will not move. That means if you give force till that much, then the body will not move. Moment you give more than that, its body will move. Clear? So what I did, my normal force upward is equal to two forces, F sine 60 and weight. So weight is how much? Root 3 into G and F sine 60. Clear? And your F cos 60 is equal to your limiting friction. And you know limiting friction equal to mu n. That means your F cos 60 equal to mu n. Now you know n is this much. You just put the value n here. So your F cos 60 equal to 1 by 2 root 3. Mu is 1 by 2 root 3. 1 by 2 root 3 into root 3g plus F sine 60. So just normal calculation. This is F by 2. Cos 60 is 1 by 2. So F by 2 will be 1 by 2 root 3 into root 3 into 10. Again 1 by 2 root 3 into F into 2 root 3 by 2. So root 3 cancel. Again here root 3 cancel. So F by 2 equal to 10 by 2 is 5. Here F by 4. Take this side. F by 2 minus F by 4 equal to 5. So this will become how much? F by 4 equal to 5. So F equal to 20 Newton. So 20 Newton is the maximum force. If you give force till 20 Newton, the body will not move. Moment you exceed 20 Newton, if the question will ask, what is the minimum force? What is the maximum force till what the body, or minimum force when the body will start moving? Then you should say, moment you give more than 20, the body will start moving. Clear? Clear?
Sir, one second, sir.
Note down, note down, note down. So was this clear? Was this taught like that, Pritam, in your class?
What, sir?
Or did they teach you like this, or did they teach you in different way?
Sir, no, sir. Like, I don't know, sir. Like, I'm not familiar with this sum, sir.
Okay. Yeah, easy sum, yeah, nothing big deal. This is a basic sum. Swarup clear, Laksh clear.
Sir, F is equal to 20 only, no, sir?
Yeah.
Yes, sir. Clear, sir.
Sir, what have you put, sir? Like F is equal to 20 Newton only,
Newton.
no, sir?
Newton.
Yes, sir. Yes, sir, understood, sir.
So now we will go to one more concept. Now you tell me, guys, all of you, I'm asking you, there is a body, okay, some weight. Is it easy to push or easy to pull? Obviously, you will stand here like this, and if you stand here, you will try to push like this. So is it easy to push or easy to pull? Which is easier? Pulling is easier, pushing is easier. Answer, come on. Pritam, Laksh, I'm asking you a question. Push is easier. Okay, Swarup is saying push is easier. What about
I also think it's push.
Laksh is saying push. What Pritam, what you are saying?
Sir, push, sir.
Okay. So majority win. I am saying pull. We'll prove it mathematically. Okay. We will prove it mathematically. Whether push is easier, pull is easier. Okay. Hold on. Okay. Carefully see. Yeah. Very important. Okay. You have an object M. Okay. You are trying to pull it. You're trying to pull it. So obviously it will make an angle theta with respect to ground. Obviously this will have a weight mg and there will be a normal reaction. Clear? Okay. So whenever F is there with an angle, you will have a what? You will have a upward component this side F sine theta and this component F cos theta. So what we will do? Your n plus F sine theta equal to mg. Yes or no? F cos theta this side, obviously there will be a limiting friction this side, FL. And your FL equal to F cos theta. Clear? So what will be your N? Your N will be mg minus F sine theta. So your F cos theta will be equal to how much? Mu n. So mu into this one, mg minus F sine theta. Clear? Clear or not? Pritam, Laksh, clear or not?
Yes, sir, yes, sir.
This is your answer. This is your FL. Keep this FL. Write down somewhere. Write down. So I am rubbing it. Okay, I am rubbing it. I will explain. I'm
Yes, sir.
just putting it. I'm just putting it aside. So what we got? We got this much. This is your FL. For how much? For pull. Now we will find for push. Okay. Same. So now we will take again a object. We will try to push it with F. It will make an angle theta. So obviously when angle theta, this also will be theta. So here it will be F cos 60, downward will be F sin 60, downward will have a weight, upward will have a N. So now your N will be equal to W, N equal to, sorry, mg plus F sin theta, and your FL equal to F cos theta. So FL will be mu N. So your mu N will be how much? N will be, you put this formula, it will be mg plus F sin theta. So now for push, it was mu into mg minus F sin theta, and for pull, for push, this is for pull, and for push it is mu equal to mg plus F sin theta. Now tell me which force is greater. This force is greater or this force is greater?
Push, sir.
Which is greater? Push greater. If push is greater, if this force is greater, that means more friction is acting. That means you will have a tough time. Yes or no?
Yes, sir.
Then how can you say that push is easier then?
Yes, sir. Understood, sir.
Clear, Laksh? Swarup, remember, always pull is easier. Have you ever
Yes,
seen?
sir. Understood.
So in physics, it proves. So that means your F sin theta is the component which is getting added, but while pulling, it is getting subtracted. Okay. So F sin theta is the adding up. It will increasing your frictional force, eliminating friction. While if you pull it, your F sin theta will decrease, because F sin theta acting in pull, it is acting upward. In push it is acting, in push it is acting downward. In pull it is acting upward. Clear? That is why friction is more in the case of push than in the case of pull. So it is advised that you all should pull the object than pushing the object. Clear?
Sir,
Yeah.
like for example, if the theta is 0 degree, then both will be equal, no, sir?
If theta is 0, yes, of course. Of course, no? If theta is 0, then to nothing, no? But theta is never 0. Have you this? There is a small object. You are standing here. Will you bend down and push, or you will push like this? You will always give a angle, force at an angle. Yes or no?
Yes, sir.
You are talking about a special scenario, Pritam, where you are giving a theta is 0. It is never. You can always have some kind of angle. Okay. You always give some kind of angle. You will never give exactly theta is 0. You never give force like this or like this. Clear?
Okay, sir.
Clear, no? So Laksh, Swarup,
Yes, sir. Clear, sir.
now we will study one more concept. What is angle of repose? Angle of repose is the maximum angle on the inclined at which the body is at rest. That means there is an inclined plane. If I keep a body here, it will slip down. Okay, the body will slip down. Am I correct? So now this is called the angle of repose. If let's say I am keeping the inclined plane like this, theta, reducing the angle theta, this theta 1, this theta 2, theta 1 is greater than theta 2. Now I am giving still lesser, theta 3. Now theta 1 is greater than theta 2 is greater than theta 3. Now in this case, the body is not moving, the body is at rest. But in these two cases, the body is slipping downwards. So what is the maximum angle? What is the maximum angle for which the body stays at rest? or you can say it is the maximum angle at which the block just about to slide. About to slide means the moment you increase, the body will slip down. So what is the maximum angle? What is the maximum angle? So maybe this is the maximum angle, or maybe this is the angle. So at what angle? Maybe the body is not moving here till, that means you are increasing theta 3 to theta 2 to theta 1, till now it is not moving. Moment you give theta 1 little more inclination, the body will start moving. Am I clear?
So can you explain this again, sir?
So angle of repose means basically it's an inclined plane. I'm talking about, see, you have an object like this. It is exactly horizontal. If you keep a body, there is no case of sliding. But let's say I am slightly inclining it, increasing theta. The body will still not move. Again, I'm increasing this one to here. The body will not move. But let's say I'm increasing it further a bit, then the body will slide. So what is the maximum angle? What is the maximum angle? The body is not sliding. So body is not sliding here also. Body is not sliding here also. But the moment you increase this theta above this, the body will slide. Clear? So that maximum angle is called angle of repose. Clear?
Yes, sir.
Laksh, clear?
Sir, so that angle
Yes,
of
sir, yes, sir.
inclination is called angle of repose now, sir.
Yes. Okay?
Okay.
Clear? Okay. So let us see. This is a definition, but we will come to the calculation. We'll see the forces. So I have an inclined plane. I have a body of mass m. Yes. So obviously there will be a mg downward. This will be theta, and you know very well that there will be a theta will be a what? There will be a component mg cos theta, and there will be a mg sin theta downwards, and there will be a normal upward. And obviously there'll be, because the body is trying to slide, there'll be a limiting friction. Always remember, friction always acts opposite to the relative motion. If the relative motion this side, friction will act this side. If the relative motion this side, friction will act this side. So friction is always act opposite to the relative motion of the body. Clear? So I told you this angle is theta. Already explained you why this is theta. Previous example, I have told you why it is theta. So now what? Your n equal to normal equal to mg cos theta. Yes or no? And your F, limiting friction, is equal to mu into n. So mu into mg cos theta. Your FL. Yes or no? So what do you have to find? So value at, so the maximum value at which the block will be a left. That means if your FL is equal to mg sin theta, if this force is equal to this force, that means the body is not moving. The moment body will start moving only when your mg sin theta is greater than FL. If your FL is greater than equal to mg sin theta, then the body will be at rest. Moment mg sin theta is greater than FL, the body will move. So the body to not to move, FL should be equal to mg sin theta. Clear? So that means your FL equal to mg cos theta. Now this two equation, this equation. So mg sin theta will be equal to mu into mg cos theta. So mg gone. So sin theta by cos theta equal to how much? Mu. That means tan theta equal to mu. So theta equal to tan inverse of mu. So in this also, this theta is called repose. Previous what we studied, angle of friction. There it was angle of friction, theta f, which is also same tan inverse of mu. And here angle of repose, also tan inverse of mu. Clear? Clear?
Sir, angle of friction and angle of repose, like both are same, sir.
Both are not same. Both are different example. Angle of friction is basically the result, the angle between the resultant and the resultant contact force and the normal force. But the angle theta is the angle between the, it is the inclined plane, this theta or this theta. This, if you increase this theta, obviously this theta will also increase. Yes or no? Yes or no?
Yes, sir.
Two different things. But yes, formula wise it is same.
Okay, sir. So one second, sir. I'll copy this.
Yeah. Clear now, Swaroop? Good. So I think with this the chapter is over. With this the chapter is over. One more two problems we'll do. We will by tomorrow's class we'll complete this chapter. We'll do some more problems and we will start a new chapter. Clear all of you?
So one second, sir. I'm writing, sir.
Yeah, no problem.
Sir, the angle of friction, like, can you like mark where the angle is, sir? Like, it is between what, sir? So no, sir. I'm asking in an inclined plane, sir.
You have angle of friction, no? You should tell angle of repose.
Yes, sir. Oh, okay, sir.
Or this theta, this same, yeah. This theta is same only, no?
Oh, okay, sir. So angle of repose comes like only in a
Yeah, angle of friction comes for normal if the body is like this. Angle of repose comes for body on inclined plane.
okay, sir.
Clear? Just a moment. I will write something that will be useful for you. With this, we'll complete the class today. We'll continue tomorrow. Tomorrow we have what time? 7 o'clock, right? Okay. There are three
Yes, sir. Yes, sir.
cases. Three cases. If
So no, sir. Tomorrow evening 5:30, sir.
5:30, yeah, yeah. If theta is greater than theta r, if the angle theta is lesser than theta r, no sliding. The sliding will not happen. Body is at rest. And your static friction will be equal to applied force. Next case. If theta equal to theta r, just about to slide. Okay. And here same, your FL, limiting friction, equal to mu s into n. And if theta is greater than theta r, body starts to slide and your Fk equal to mu k into n. Write down this. Very, very important. Okay, students.
Sir, 1 second, sir. I'm writing, sir.
Yeah, no problem.
Sir, I have a doubt, sir.
Yeah.
Sir, theta r is the angle of repose. Theta, like what you are saying, sir.
No. Are Baba. I am saying, what is theta r? Theta is the maximum angle at which it slide. So I am saying if the theta, if the angle is lesser than theta r, let's say theta r is some 30 degree. If my angle of the incline is 20 degree, so when it is 20 degree, obviously for a particular body, for a particular mass, there will be a specific theta, no?
Yes, sir.
Yes or no?
Oh, okay, sir. Yes, sir. I understood, sir.
Okay. If I am saying that if for a particular theta, theta is constant, okay, because theta is dependent on what? Mu, and mu is dependent on what? Mass. Am I correct?
Yes, sir. I understood, sir.
Okay. So see you tomorrow then.
1 second, sir.
Yeah.